Greetings to you. Welcome to Physics with Ben. In today's video, I want to teach you how to plot velocity time graph and do all the calculations therein. So we don't need to waste time. I want you to pause this video, go and get this with you, your calculator, you get a graph sheet, yes, preferably WAEC standard, and then get a pen with you. So let's start quickly. This is we are looking at book 2. This is the topic. Yes, this is it. But we want to solve this exercise, question number 17. I read question number 17. That is exercise 2, question number 17. The uniform acceleration, define uniform acceleration, A plank is raised at one end in order to form an inclined plane. A light freely running trolley travels from rest. Take note, travels from rest down the plane. The time to travel from different points to the lower end of the plank are measured and the following results are obtained. So the question is, draw a graph to show that the acceleration is uniform. Underline acceleration is uniform and calculate its value. Use this calculated value, to calculate the velocity which the trolley would acquire if it traveled 400 cm from rest along the same inclined plane. This question, trust me, is a very technical question. We will not waste time and we'll go straight away to solve this question. Solution. I told you to look for a graph sheet so that we can do it together. So we'll start. This is question 17. Question 17. Solution. So I want to look at something here quickly. We have this. Let's generate our table of values. We have distance in cm, and then we'll have 0, and then we'll have time in seconds. When distance was 0, time was 0, telling you that they both start from rest. So when distance was 50, time was 1.4 seconds. When distance was 100, time was 2.0. When distance was 150, time was 2.5. When distance was 225, time was 3.0 seconds. When distance was 325, time was 3.6 seconds. This question looks very simple, but it is not simple. Now, I want to recall something quickly. In physics, when we are discussing about these graphs, a distance time graph will give you the speed of a moving object. Displacement time graph will give you the velocity of a moving object. And then we also have velocity time graph, which will give you the acceleration of a moving object. But this question, we are having distance and time, and these guys are asking us to find the acceleration with which the trolley is moving with. Is the acceleration uniform? It's a technical question. Now, let us look at the equations of a uniformly accelerated motion. Recall that from A is equals to, that is acceleration equals to V minus U all over T. This implies that V minus U is equals to AT. This implies that V is equals to U plus AT. So V is equals to U plus AT is the first equation of motion. The second one, you have distance S is equals to UT plus half AT square. Call this equation 2. The third one is V square is equals to U square plus 2AS. We call this equation number 3. Please take notes. V square is equal to U square plus 2AS. So the equation we are going to use to solve this technical question is equation number 2. So meaning we are going to include T square S square in this table. So quickly, let's say we have 1 point. We have 1 point. We'll square every value here. We have 1.4 square. Our result is 1. We still have 0 down here. 0, 0. So we have 1.96. And then we have 3.6 square. We have 12.96. Now we are done. So we are going to use this on the vertical axis, that is on the y-axis, and this on the x-axis. Now let us form the equation for this graph. From equation 2, from equation number 2, it implies that our distance S is equals to, for equation number 2, U is equals to 0 because they are starting from rest. So initial velocity is equals to 0. So it means that we have 0 times t plus 1 over 2a this. So this will strike out. So you have your S is equals to half AT square. If you write this very well, you are having something like S is equals to A all over 2 times T square. You can call this equation number 4. This equation looks like Y is equals to M times X. That is a straight line graph with no intercept. This is how this graph will look like. This graph will pass through the origin with no intercept. If you have something like this, something like this, you have Y on the vertical axis, and then you have X on the horizontal axis, and then 0, 0. So the graph will pass through the origin, and then your intercepts, this is change in Y and this is change in X. So the slope of this graph becomes change in Y over change in X. So in this case, what we are going to have here is something like this. We're going to have this up here will be our distance in centimeters, and then because they are starting from origin, this we go this way, and this will be our T square over S square, 0, 0. They will both start from the origin, and then the graph will pass through the origin, and then the slope of this graph will be change in distance over change in T square. So this is the equation for this graph. You have S is equals to A all over 2 times T square. So the slope of this graph will be change in S over change in T square. So the slope of this graph is the same thing as what? Acceleration all over 2. Slope is acceleration all over 2. You can screenshot this quickly. This is it. This is it. This is it. Yep, we are good to go. So the name for our graph will be distance versus time square graph. Here will be here will be In place of y, we'll have our s. And in place of x, we'll have our t square. So the scale for the graph, for this, the least value is this. The highest value is this. The least value is this, and the highest value is this. So we are going to say for this, we'll say 2 cm. Let 2 cm to represent 50 units. 2 cm to represent 50 units. Also 2 cm to represent 2 units. 2 cm to represent 2 units on t square axis, and the other cm to represent 2 cm to represent 50 units on t square axis. The next thing to do is to draw our line, our vertical line here. We'll draw this line straight. We'll use this point from this point down. So we'll use our ruler, our pencil and a ruler, draw this line straight. Draw it straight. Do you see that? And then you will indicate an arrow here. This is necessary, you put this arrow, because if you don't, the examiners will mark you down. And then we'll draw another straight line here. Yes. Another straight line here. Another straight line. That will pass through here. Take notes. We are leaving just a box. Then this line. Yeah. Since our graph is starting from the origin, we now write 0, 0. So here, direction of the graph, this is arrow, this is t square second square. T square second square. This is your graph. So 2 cm to represent 50 units means that each cm, now this is y standard graph. From here to here stands for 2 cm. 2 cm means 10 small boxes. So 1 cm means 5 small boxes. This is 1, 2, 3, 4, 5. This is 1 cm. 1, 2, 3, 4, 5. This is 2 cm. You get it? So each 2 cm will be adding 50, 50. So this is 50. This is 100. This is 150. This is 200. This is 250. This is 300. This is 350. That is it. So that is the progression. And then this side we'll be adding 2, 2. This is from 0 to here. This is 2. 2 plus 2. That is 4, 6, 8, 10, 12, 14, and then 16. This is it. This is your graph. 4, 2 in that order. Now the next thing to do is to plot, is to get the value for each small box. This horizontal axis, 2 divided by 10 will give us 0.2. 2 divided by 10 will give us 0.2. So 0.2 is the value for each small box here. 50 by 10 will give you 5. The value for each small box here is 5. These values are very, very important when we want to. So this is for up here and this is for this side. Are very, very important when we want to plot graph. So we want to start plotting our graph when distance was 0, t square was 0. This is where they intersect. This is where both of them are 0. This particular point here. So you start this place. This is where both t square, distance, and t square are 0. You start your graph from there. Now when distance was 50, t square was 1.96. 1.96. If you want to know the exact value, 1.96 divided by 0.2. It is somewhere around this region here. So we can say approximately that is 2 cm. So this is where 50 and 2 cm intersects. This particular point here. So when distance was 100, t square was 4. 100 is here, 100 is here, and this is 4. This is where they intersect, this point here. When it was 150, it was 6 approximately. Or if you don't want to do it that way, that is 6.25 divided by 0.2, it will give you 31, meaning 31 small boxes. So this is 10, 20, 30, 31 is somewhere here. So 31 against 150. So where is 150? This is 150. 150 is somewhere here. You trace this up here. So this is where they intersect. Yes. So when it was 225, when distance was 225, t square was 9.00. On your graph, this is 2. This is 250. 225 is half of this. So this is 1, 2, 3, 4, 5. This is where 225 is. 225 against 9. Put your ruler straight on this line. And this is 8. Half of this is 9. So this is 1, 2, 3, 4, 5. So you trace this line up here. This is where they intersect. This is 225 against 9. Then the last value is when distance was 325. This was approximately what? Time was approximately 13. So 325. So the last value is when it was 325, it was approximately 13. So this is 325. 325. This is 350. 325 is half of this. This is 1, 2, 3, 4, 5. So you put your ruler here, and then this is 12. 13 is half of this. That is 12.9. 13 is half of this. This is 1, 2, 3, 4, 5. So this is 5. You trace this line up here. Yes, this is it. So this is the point. This is the point. Sorry about that. My camera was about to fall. I have to pick it up. Sorry. I'll just concentrate on the content. This is it. So we are done with this. Now we draw the line of our best fit. The line will pass through this point. Watch what I'm doing. So I'm done now. You see that? So line will pass through this. Draw it once, not twice. So as predicted, I told you this line, this graph will look like any of this. Do you see that? Exactly what I predicted. Look at it here. It is a straight line graph passing through the origin. The second thing we have to do now is to draw our slope. So we take our slope from this point, our large triangle from this point to this point to this point. When drawing a slope, you have to draw a big triangle. This will help minimize a lot of error in your experiments, in your graph work. So this is it. So here this is dot, 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 dot. And this is dot, 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 dot. So here is change in t square. Here is change in s. So we'll not stop there. Another, this is dot, 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 and then this is dot 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 dot, as simple as that. So this is your t square 2, and this is your t square 1, and here is your s2, and here is your s1. So your slope is giving us change in s over change in t square. This is the same thing as s2 minus s1 divided by t square 2 minus t square 1. If you do that, what you have here as your s2 is 300, so this is 300. Your s1 is 50 minus 50 divide by 12. Your t2, look at it here, t2 one is 12. 12 minus 2, this is your t square 1 minus 2. If you do that, you'll be having 300 minus 50, that is 250. Divide by 10. This will go, this will go. So you have 25. So your slope is equal to what? 25. What's the unit? The unit is cm. 25, this is cm over what? Over s square. This is the value for your slope. And recall that I told us that this slope is the same thing as m. So as 2 all a all over 2. So we are saying that our slope is equal to what? A all over 2. This implies that 25 cm s square is equal to what? A all over 2. They asked us to find the acceleration of the body and to tell if the acceleration on the graph is uniform. The answer is yes. The acceleration is uniform because this is a straight line graph. Distance versus time square graph will give the acceleration of a moving object as well as velocity time graph. So this is the equation for this graph. We have our s is equals to a all over 2 t square in the form of y is equal to what? mx. This is it. This is it. Take note. So acceleration from here is the same thing as a is equals to 2 times 25 cm this. Approximately the acceleration is what? 50 what? Cm this square. This is the value for the acceleration. The next thing they ask us to find from this is use this same value. Use this same value here to calculate the velocity. They ask them to find the velocity with which the trolley is moving, and find the velocity which the trolley would acquire if it travels with what? Distance of what? 400 cm from rest, meaning when u is equal to 0 from rest on the same inclined plane. So I listed 3 equations here. We have used this one, so we're going to use this equation 3 right now. So equation 3 states that v square is equal to u square plus 2as. S is the distance, which is 400 cm, and a is acceleration, which is s is the distance, which is 400 cm. This is this. Then acceleration a is 50 meter, and then u is 0. So we have v square is equal to 2as. So v is equal to the root of 2as. So this is the same thing as the root of what? 2 times 50 times what? 400. If we do that, we are going to have the following. This is what we have. We're almost done with the question. So we'll be having the root of 4,000 and root 4,000. Sorry, that should be 40,000. 40,000. 2 times 50 times 400 will give us 40,000, and root 40,000 will give us 200. Yeah, give us 200. So in this case, our velocity is what? 200. What's the unit? What's the unit? The unit is simply what? cm/second. This is it. We can convert this to meters per second if we want to. So this is the acceleration the examiners asked us to calculate. This is correct, and this is the velocity. This is also correct. This is exactly how your solution, this is a slope. This is exactly how your work is supposed to be when you are presenting it to WAEC examiners. And this is your slope, your graph as was required. Thank you, and God bless you. See you in another video.